Yesterday we have discussed about what is the data warehouse and what is the data mart, and today we will discuss about data lake and what is the data pipeline and what is data mesh and then data lake house, and also various types of data loading methods like ETL and ELT, as well as the batch processing and the stream processing. Okay, so data warehouse is a centralized repository that stores large amounts of structured and semi-structured data from various sources within an organization, right? So data warehouse, it is designed to support business intelligence activities such as data analysis, reporting, and decision-making purpose. And these are typically employ a process known as extract, transform, and load. Okay, so what does that mean? Extraction is nothing but uh, extraction is the first step, okay, in both this ETL or ELT. This step is about collecting the raw data from different sources. These uh, this could be databases or files or software applications or IoT sensors or application events. So also we can collect semi-structured data, structured data, or unstructured data. Okay, that is in the extraction process. So this is there in all the areas. It may be in a data warehouse, a data mart, or in a data lake. Okay, so this process is needed. And transformation is nothing but it's the second step. While in here, this step focuses on changing raw data from its original structures into a format that meets the requirements of the target system. Okay, and then maybe it may be changing of data type formats, data types or formats, removing some inconsistencies of data or inaccurate data, and removing data duplication. All these comes under transformation process. Okay, and then the final step, loading. Loading means in this phase we store data into a target database. Okay, in this ETL process, load data as if means is the final step, so that the reporting tools can use it directly to generate actionable reports and insights. Okay, and this is the data mart. Data mart is a subset of a data warehouse. Okay, it also has the same process, ETL process, extracting the data from data sources and loading into a staging area, and there we perform all the transformations, and at the end we load the data into this data warehouse. This data warehouse again can be subdivided into different data marts based on their domain, a specific subject area. It is called specific subject area, like purchasing, sales, inventory, and these are directly accessible to these users. Okay, through analytics or to reporting or to mining. So this is about data mart. Data mart is a subset or a specialized version of a data warehouse. It is focused on a specific business function or department within an organization. Okay, data marts are created by selecting and aggregating relevant data from the data warehouse and transforming it to align with the requirements of the specific business area. So this process is known as data marting or data mart creation. That is about data mart. And these are the benefits and characteristics of data marts. Okay, that we discussed in the yesterday's session. Now we'll move on to the data lake. So this is the data lake architecture. Here also we have different source systems. It may be business applications, or it may be the enterprise data warehouse, or it may be some documents, or it may be Salesforce kind of SaaS applications, or device logs, or IoT sensors. So different sources are there to extract the data and processing it in this processing layer. Okay, here it is called a lake, nothing but here we store the data in the form of object storages and metadata storages and also replications. Okay, here we apply all the security and data governance rules. And finally, through these API gateways, we can load the data into these targeted databases. Okay, now we'll see that a data lake is a centralized repository that stores large volumes of structured, semi-structured, and unstructured data in its raw or native format. Unlike a data warehouse or data mart, which follows a predefined schema and structure, a data lake allows for the storage of data in its original form without the need for upfront transformation or normalization. Basically, the main difference of the data warehouses and data lake is there we store the data in a structured way, in a structured format, like in a dimensional modeling format. But here there is no structure. In that sense, there is no data modeling applied. So as it is, we are loading the data from the source systems. It's the raw data. Okay. In a data lake, data is stored in a flat architecture, typically using a distributed file system such as Hadoop, cloud-based storage systems like Amazon S3 or Azure data lake storages. Okay. So these are the different platforms we can use it for uh, creating these data lakes. So in our AWS, here we use S3 buckets. Okay, simple storage structure. Okay, here the data lake can accommodate various types of data, including text files, documents, sensor data, as we have seen in the diagram, log files, social media feeds, more. And these are the benefits or the features of a data lake. Storage of diverse data. A data lake can store structured, semi-structured, and unstructured data from different sources without enforcing a specific schema or data model, as we have discussed about that. So here, there is no specific structure or a schema. It is a raw data. This flexibility allows organizations to capture and store vast amounts of data in its raw format, preserving the data's integrity and enabling future analysis. And the scalability. Data lakes are designed to handle massive volumes of data, making them highly scalable. They can scale horizontally by adding more storage nodes or by leveraging cloud-based storage resources, ensuring the data lake can accommodate the growing needs of the organization. So it is providing us the scalability feature. And schema on read. In a data lake, the structure and schema of the data are applied when the data is accessed or queried rather than during the data ingestion process. Okay, this schema and read approach provides greater flexibility for data exploration and analysis, and as users can interpret and transform the data based on their specific needs at the time of analysis. So this is a schema on read. So directly they can read the data from these data lakes. Later they can do their transformations. Okay, and data exploration and discovery. Data lakes encourage data exploration and discovery by offering a wide range of data sources and formats. Analysts and data scientists can explore and experiment with different data sets, combine and correlate data from various sources, and uncover hidden insights or patterns that may not have been apparent before. So this is the another feature of data lake, data exploration and discovery. And the integration with analytical tools. Data lakes integrate with various analytical and processing tools such as Apache Spark, Hive, and machine learning frameworks, allowing users to perform complex analytics and derive meaningful insights from the data stored in the lake. So everything is available on this storage device, so that these within these tools we can integrate for this analytical purpose. And data governance and security, this is very important. Actually, earlier in data warehouse, in data marts, we don't see this data governance, but here especially data lakes and the future technologies like data mesh and data lake house, so this is mandatory. Data lakes require robust governance and security measures to ensure data privacy, compliance, and access control. Data governance practices such as data cataloging, metadata management, and data lineage help maintain data quality, track data provenance, and establish data usage policies. So this is a very important task to maintain all these, security measures and the data governance practices. This is the task of data engineers only. Suppose if it is a big organization, they will recruit the other member to take care of this step or this activity. Okay, and smaller companies and medium-sized companies, they will assign this task to data engineers only. Okay, data democratization. Here, data lakes promote data democratization by providing self-service access to data for different user groups within an organization. Okay, business users, data analysts, and data scientists can access the data lake, discover relevant data sets, and derive insights without heavy reliance on IT or data engineering teams. So here, data democratization, it is promoting the data to provide the self-service. Okay, that means here it seeks to make data more accessible to non-technical users also. Okay, in part only, by making the tools that access the users, that is easier to access, as it is the data, entire data is available, so they can access the data from the data lakes. Okay, these are the main characteristics of and features of data lakes. And coming to data pipeline. Okay, here there are different stages in the data pipeline architecture. Let us see what is a data pipeline. A data pipeline is a set of processes and technologies used to extract, transform, and load data from various sources. See, as I told you, ETL job is the important job of a data engineer. Extracting, transforming the data, and loading it into the target storage. Okay, this is finally for analysis purpose. Okay, it involves a series of steps that move data through the data pipeline, ensuring its quality, reliability, and accessibility. Okay, the main components of a data pipeline. You understand this concept. A data pipeline is a set of processes and technologies used to extract, transform, and load. So when you see this diagram here again there are different source systems, mobile applications or web applications or microservices or IoT. There may be any type of source here, and basically this process is uh, divided into two types here, that is batch processing and stream processing. So that also you need to understand this concept. Okay, what is batch processing? See, suppose uh, when ask a big questions like remember your last year's tax statement. Okay, so what we'll do, you break out the folders, then you run around the house searching for the receipts, right? So all that is a stuff And when you finally found everything, you will fill out the form and send it to the respective person or respective tax department. So doing this tax statement is the prime example of a batch processing. Okay, data comes and comes in and gets stored. So let us see. I'll show you one small diagram here. Uh, this is storage. This is storage. Then this is going to analytics. Let us take this one. So data is coming to this storage device, and then here the insights of that data is going to be, this is the final step of this batch processing. Yes. To show you the differences between batch processing and stream processing. This is the data. Okay. Here, data comes in and gets stored. Analytics loads the data from storage and creates an output that is called the insight. Batch processing is something you do either without schedule or on a schedule. It is used to ask big questions and gain the insights by looking at the big picture. Okay, so to do so here, batch processing jobs use large amounts of data. This data is provided by storage systems like Hadoop, HDFS. Okay, they can store lots of data like a petabytes of data without a problem. And the results from these batch jobs are very useful, but the execution time is high because the amount of data is high. Okay, it may take sometimes minutes or sometimes hours until you get your results. But whereas when in stream processing allows the users to make, so this is the batch processing. Whereas when you come to this stream processing, here you can take the same picture, but the data comes in to this analytics space here. Here, now if it is possible or not. Okay. Here in this stream processing, a users allows to make quick decisions and take actions based on the real time. So that is called the real time applications. With contrary to the batch processing, stream processing, in the stream processing data on the fly as it comes in, like So here the analytics takes place here itself on the data itself here, here, and the storage later we store the data. And before that, they'll analyze here itself by taking these insights here. Finally, these functional. Okay. So this is the stream processing. In stream processing, the users allows to make quick decisions and take actions based on the real-time insight. Okay. But whereas in batch processing, it is after loading the data, then only they'll take that into analytics and then they'll see that insight. That is the basic difference between batch processing and stream processing. With stream processing, we don't have to wait minutes or hours to get the results. We gain the instant insight into the data. In the batch processing, the analytics was after the data storage. So here, after the data storage, it had access to the all the available data. But whereas in stream processing, that creates the insight before the data storage. Before the data storage, it has only access to fragments of data as it comes in. So that's why it is called a real-time processing. So only with stream processing, stream analytics, we are able to create advanced services for the customers. Like example, when you see Netflix. So Netflix is one of the good example. It uses the advanced services through stream processing, and it is showing some trending now feature, etc. That is a good case study for stream processing applications. Okay, and coming to our here in this data lake, the data can be processed in a batch mode or a stream mode. Here, see, this is the stream processing. This is the batch processing here. Here batch processing. The data is loaded into this data lake. In our AWS, we call it as S3 buckets. Okay, and here all the data is stored in this entire data lake, and that can be used any of your depends on the business requirement. We can use it for stream processing or batch processing. Okay, and whenever you see this, this light colored, this is the stream processing job. So here that data is instantly coming and storing on fly, in the sense we use the cache memory for that. So these are the different stages in this data pipelining. So capturing the data, ingesting the data, storing the data, and computing and processing the data, and using that, finally using the data. So building this entire orchestration is the job of a data engineer. So here it contains that orchestration, data quality, data catalogs, and data governance techniques. We need to apply all those practices. So this is a basic data pipeline architecture. So this is the event queue. This is extracting the data in the form of event queuing. Here we are extracting the data in the form of a batch data loads. So to do all this process, we use different tools in our AWS cloud platform. Okay. The main components of a data pipeline in that these are the data, these are the main components in the data pipeline. Data ingestion. Data is collected from different sources such as databases, applications, APIs, files, or streaming platforms. It can be real time or batch data. Means it can be a stream or a batch data. And data transformation. The second step. The ingested data is to be processed and transferred according to specific business rules like cleaning the data and aggregating the data, filtering the data, and enriching the data as needed. So this step ensures the data consistency, quality, and conformity to the desired format. So here the SQL part comes into picture. So we need to know some SQL commands to filter out and to aggregate and to clean the data. Nothing but in the data transformation process, we need to apply some SQL commands. Okay. And the data storage, the transformed data is stored in a suitable data storage system or repository. This can be a data warehouse or a data lake or a cloud-based data storage service or any other storage solution that fits the requirements of the pipeline. This is the next step. In this here data storage, here after ingesting the data, this is storage is the next step. Okay. So here we will use some different techniques like for storing depends on the business use case. We may use the data warehouse like a Redshift, or we may use for stream processing we may use the other tools like serverless computing process like lambda functions or glue, and Kinesis is stream processing purpose. So we will apply all those tools based on our requirement, the business case study. Okay. And data integration. In some cases, data from multiple sources needs to be integrated and consolidated. This involves merging data from different systems or databases to create a unified view of the data. So we may be combining based on the common columns or common data. So that is nothing but a data integration. Then data validation and data quality control. The data pipeline process often include data validation checks to ensure data accuracy, completeness, and adherence to defined business rules. Quality control mechanisms may involve data profiling, anomaly detection, and the data cleaning techniques, data cleansing techniques. These are all the different data validation steps. So this is also one of the major tasks of a data engineer. And data movement and orchestration. Data movement involves transferring data from one stage of data pipeline to another. Orchestration involves managing the flow of data, scheduling tasks according to the execution of different pipeline components. Like we may use Apache Airflow or a Kafka, okay, along with our AWS tools for the data orchestration purpose. The scheduling the tasks, the scheduling the pipelines, and the workflows. So there we use that scheduling and the various tools for that. See, you don't worry about here we don't write any coding. Just we need to learn how to use those tools to do these tasks. That is our job as a data engineer. And the data delivery and consumption, this is another component in a data pipeline. Once the data is transferred and stored, it is made available for consumption by downstream applications, analytic tools, reporting systems, or other data consumers. This can be through APIs, dashboards, data access layers, or direct integration with target systems. But this is not your job. This is the consumer's job. Like this end job is like data scientists or the data analysts. They can create these type of the task, like reportings and applying some models, machine learning models on the available data. Our task is to get that data from these sources and apply that validations and quality checks on this data lake, and whether it may be a stream processing or it may be a batch processing. We need to learn these tools to do these two types of tasks. Okay, and these are the main components of a data pipeline. Then benefits of a data pipeline, the uses of a data pipeline. Data reliability and consistency. Data pipelines ensures that data is processed consistently, adhering to defined standards and rules, resulting in reliable and consistent data across the organization. And data freshness, real-time or near real-time data pipelines enable organizations to have access to the most up-to-date information, supporting timely decision making and insights. And this is the other benefit of a data pipeline. And then automation and efficiency. Data pipelines automate the extraction, transformation, and loading process, reducing manual effort and improving efficiency in data integration and analysis. This is the other benefit of a data pipeline. And scalability. Data pipelines can handle large volumes of data and are designed to scale horizontally to accommodate increasing data volumes and processing demands. So it depends on the need of a volume or the size of a data. We may be scaling out horizontally by adding some of the resources. And data governance and compliance. Data pipelines facilitate the implementation of data governance policies, data lineage tracking, and compliance with regulatory requirements by ensuring data quality and traceability. So these are the main benefits of a data pipeline. See, again, this is the in 1980s, data warehouse model looks like this. Here, external data sources from the operational data. This is the OLTP systems, and by using these ATL tools like Informatica, Talent, Avencio, Teradata also has their own tools to do this ETL process. And this data is stored in this data marts, like depends on their like domain. It may be different subject areas, like sales data, the inventory data. Okay, and this is entire step. Maybe this is this may be the kind of a, as I told you, data warehouse or a data mart. This is the late 1980s, and coming to 2011, a data lake came into the picture. So here only we use that OLTP systems from the external data sources, but here the data is in different formats like structured, semi-structured, unstructured data, like from images, kind of video streaming, or audio, documents, that transactional database also. And here this is the here the applications here, machine learning purpose, data science applications can use this data from this data lake, and it may be processed with in the form of a batch processing or real-time stream processing. And with the help of these reporting tools, they will get these reports. And lake house, that we will discuss. Data lake house means here the term data lake house refers to a data architecture that combines the best aspects of data lake and data warehouse. It is a combination of both data lake and data warehouse concept. It aims to provide a unified and flexible data platform that can handle both traditional structured data and newer forms of semi-structured and unstructured data. We need to remember this thing here that combines the best aspects of data lake and a data warehouse. This is the data lake house. And in a data lake architecture, data is stored in a centralized repository like a data lake, which allows for the storage of raw and diverse data in its native format. That means we don't do any processing. We don't do any transformations on the data as it is, as that comes from the sources. The same data is going to store in this data lake house. This enables organizations to capture and store vast amounts of data without upfront data transformation. Okay. However, unlike a traditional data lake house, a traditional data lake, a data lake house incorporates some key elements of a data warehouse to improve the data organization, processing, and query performance. To improve the data organization, processing, and query performance. These elements include schema enforcement, indexing, and optimized query engines. Let us see that. Sorry. Yeah, here. This in here. Here also, this is a combination of it. It can be based on these two architectures. It is built. Like this one is lake house. But this is used only big companies, those who are implementing machine learning applications and data science applications and AI applications like that. See, that's why we see here that the data may be here operational data as well as the different kinds of data, structured, semi-structured, unstructured data here. Okay, and the benefits of lakehouse. Schema enforcement. A data lake house introduces schema enforcement, which means applying a schema or structure to the data stored in the data lake. Earlier, we don't see the structure in the data lake, but here we have to apply this schema or the structure. This helps ensure data consistency, enforce the data quality controls, and improve data governance. This is the schema enforcement is there in the data lakehouse. And optimized query engines. Data lakehouse architectures often employ modern query engines such as Spark, which provide optimized performance for querying and analyzing data stored in the data lake. So when yesterday we have seen that MapReduce is not going to be used in the current trend because it is going to take more time. That's why we have to learn this Spark. So mainly the people in this, all the companies are now using this open source stack. Like in this, especially for the transformation purpose, they use Spark or PySpark. That's where you need to learn a little bit of Python concepts also. That I'll teach you. Do you anyone knows about this Python language? Alex, Carlos, Khader. Anyone knows Python language?
No.
Other?
Just the basic.
Pardon me?
Just
No,
the
sir.
basic.
Okay, fine, fine.
Sir,
And
your screen is slightly not visible towards right side.
oh, is it? Shall I display like this?
No, still some portion is not visible towards right side.
Oh, okay. We're sharing the screen.
Is it the same for Alex and Carlos as well?
Yeah, there's a word that is cutting off at the end to your left.
Yeah, I don't see it. The right side doesn't show fully, but you can see half part of, not half, but some part of the right side is cut off.
Oh,
We can't see the last sentence.
sorry. What is that? You know, how to add this view slide. Now also same, huh?
Yes, same.
Yeah, it's the same. Maybe it's possible for you to zoom out a little bit.
I don't know how to do that. Actually, I'm trying here. Hmm, I can able to see here only part. Okay, select. No. One second, please hold on.
That's good.
Is it okay now?
Yes.
Yes, now it's good. Thanks.
Thank you, thank you. See, you have you might have told me before. Okay, fine, no problem. The benefits of a data lakehouse: the schema enforcement, optimized query engines, and the third one is indexing and metadata management. Data lakehouse architecture incorporates indexing mechanisms and metadata management to improve data discoverability and query performance. Indexing allows for faster data retrieval, while metadata management helps catalog and organize data assets for easier data exploration and analysis. See, indexing in the sense, basically, we have to create some keys on the data. So here in the metadata management, we use metadata is nothing but data about data, like using glue catalogs. Okay, this is to organize the data assets for easier and data expression analysis purpose. So it enhances the speed of the accessing the data. And the hybrid workload support. A data lakehouse accommodates both batch and real-time processing workloads. It enables organizations to perform complex analytics on large historical data sets while also supporting near real-time data ingestion and processing for time-sensitive use cases. Okay, data governance and security. As we have told, this one data lakehouse architectures incorporate data governance and security practices, including access controls, data lineage tracking, and compliance mechanisms. This helps ensure data privacy, regulatory compliance, and adherence to data governance policies. So these are the major benefits of a data lake house. And then comes to data mesh. This is the advanced data architecture. So here I'll briefly tell you about this. A data mesh is a relatively new architecture paradigm and organizational approach for managing data within an organization. Managing data within an organization. It was introduced by Jamak Dhaghani, a software architect at ThoughtWorks, to address the challenges of data integration and scalability in large-scale data environments. In a data mesh approach, the focus is shifted from a centralized data infrastructure to a decentralized model where data ownership and governance are distributed across individual domains or teams within the organization. See, here earlier the data is located in a centralized location here in our data lake or data lake house. But again, if they have the huge data, and also if they have a big it contains a big it contains a lot of domains or the subsets of the organization, so that can be shifted from a centralized data infrastructure to a decentralized model, so that here uh, the teams are distributed across the individual domains within the same organization. Here, these are the principles of data mesh. Domain-oriented decentralized teams. Instead of having a centralized data team responsible for all data-related tasks, the data mesh approach advocates for domain-oriented teams with end-to-end ownership of a specific business domains. These teams are responsible for data within their domain, including data collection, storage, processing, and analytics. That means, see here, actually in an organization, only one specific team will be there for these tasks, for this data engineering tasks. But whereas in this data mesh architecture, maybe they may be different data engineers are uh, divided into teams to look after their separate business data only. That is nothing but decentralized teams. Okay. These teams are responsible for data within their domain, including data collection, storage, processing, and analytics. Self-service data infrastructure. Each domain team is empowered to build and manage its own data infrastructure using modern technologies and tools. This self-service infrastructure provides flexibility and autonomy to domain teams to choose the most suitable technologies and approaches for their specific needs. This is called self-service data infrastructure. And federated data governance. Data governance responsibilities are distributed across domain teams. Each team is accountable for defining and implementing data quality standards, data privacy policies, and regulatory compliance within their domain. Collaboration and coordination between domain teams are facilitated through federated governance practices. See, this comes into a big picture of a data. Now you are not going to work on this kind of this is the future data. We are going to work on this data lakes only mainly. So just I am briefing out you just only what is happening in the data in the form of architectures. Okay, here principles of data mesh, product thinking and data productization. Data is treated as a product and a domain teams are encouraged to create data products that provide value to other teams or stakeholders within the organization. Data products are well-defined, self-contained units of data that are discoverable, reusable, and scalable. Okay, data as a first-class citizen. data is considered a key asset for the organization and is treated within the same importance as other software products. This means applying engineering practices such as version control, testing, monitoring, and documentation to data assets. So earlier, this kind of approach was not there because they don't value the data. Now, the major value, no major no business is involved in the data. So that's why they don't lose their data. So they keep their data and then they'll process the data as per their need and they'll use the data for their business growth purpose. So now, earlier we applied this version control, testing, monitoring, and documentation, and other techniques on the software products only. But now we are applying in this data mesh. We are applying all this version control, testing, and monitoring and documentation. Okay. Then I'll tell you about what is ETL and ELT, the major differences, because that is the major task of a data engineer. Second. So I'll tell you about the same task using our AWS only. I'll show you the diagram here itself. It is there now. See, ETL versus ELT. As I told you, this transformation takes place in the middle here. Extracting the data from sources and transfer the data and loading that data into the target database. But whereas in ELT process, first we will load the data into the targets, then we will perform the transformation. This T comes after loading, extract and load, ELT. Okay. So as I told you, what is extraction? Extraction is collecting the data from different sources, and transformation this is the step that focuses on changing raw data from the original structure into a format that meets the requirements. So here, in the form of, it may be changing the data types or formats and removing the inconsistent and inaccurate data, removing data duplication. All these are the transformation tasks. And loading. In this phase, we store the data into target database. Okay. But whereas now then how it is different here, how to differ from each other. ETL has three steps majorly. ETL has three steps. Okay, first one is we extract raw data from various sources. Second one is we use a secondary processing server to transform the data. Third one is we load that data into a target database. Okay, these are the three steps involved in this ETL process. But whereas in this ELT, it also has three steps here. We extract raw data from various sources. Okay, we load it into in its natural state to a data warehouse or a data lake, data warehouse or a data lake. Third one is we transform the data uh, as needed while in the target system. So these are the three steps, both in the ELT and ETL. But nowadays we are using ELT process. Here process in this ETL, here in this ETL process, we take the raw data, transform it, and it is in the form of a predefined data format, then loads into the target data. But here in ELT, we take the raw data, loads it into the target data warehouse or data lake, then transform it just before the analytics process. Okay. Here in ETL process, in the data compatibility, this is best for structured data. This ETL process is best for structured data. But in ELT, data compatibility, we can handle the structured or unstructured or semi-structured data. This is best for this ELT process. And the speed, ETL is slower than ELT. This is slower than ELT because it can use the internal resources for the data warehouse because ELT is faster than ETL. Okay, when we come to cost, it can be a time consuming and costly to set the ETL tools used. But whereas in ELT, that is most cost efficient depending on the ELT infrastructure we use. The security. Coming to security, it may require building custom applications to meet data protection requirements. And we can use in ELT, we can use the built-in features of the database, target database to manage the data protection. Okay. And here we have different tools. AWS provides us different services for both ETL and ELT. Okay, Amazon Aurora. This supports zero ETL integration with Amazon Redshift. Okay. Integration with Redshift. And then AWS Glue. Sorry. It is, a serverless data integration service for event driven that we will discuss. ETL and no code ETL jobs. That is a here. AWS Glue is a serverless data integration service for event-driven ETL and no-code ETL jobs. This is another tool. The other tool is uh, Redshift. Here, final one. It allows us to set up ELT workflows. and directly query the data sets from different sources. So these are the main tools we are going to learn in AWS for to do this task, to this ETL and ELT processes. Okay. Do you have any doubts in today's session? See, this is the last session, the theory session, and the next session onwards, we are going to discuss about. I'll show you our curriculum. Where is this? 1 second. Short trainings and then AWS data engineering on AWS. So this is our curriculum. All this introductory part is completed. Now we'll move on to this AWS infrastructure. The next session we will discuss about this AWS infrastructure. Before that, just I'll tell you about what are the different cloud platforms. Like I think you might be knowing about that, but even though I'll tell you what is four computing models like IaaS infrastructure as a service and PaaS platform as a service and SaaS software as a service and also other computing models. So then we will come to this AWS global infrastructure and how the data centers are managed on AWS. Now, from the next session onwards, we are going directly to this AWS cloud. Okay.